Alright, so I know I said I wasn't going to build anything, but I have a real problem. I love to build stuff, so I went ahead and 3D printed some tests. Basically, I imported into NTop a smooth ergonomic screwdriver handle that I've designed. It's just a nice smooth one. And I use the cool Voronoi emboss feature. And that let me build all these really cool, like, textured grips. And then I just 3D printed these on my FDM machine. So it's really cool. I've been playing around. I'll show you, like, in a second when I show you actually how I did this. But I played around with, like, how many cells I did. So this is about 100, I believe. This is about 50, and that's about 200 cells. And you can try out, you know, the different grips. So these screwdrivers aren't done. I still have some more design elements that I want to add to it, specifically with NTopology. So, and I'll show more in my other videos. But let's go over then to Ntop and take a look at how I did this. Okay, so you just saw my screwdriver handles. To give you a little background, a while back I designed a really ergonomic handle in Fusion 360. It's just designed to feel very good in your hand, and I could switch out what the handle did just by changing what the handle interfaces with. So I did screwdriver, obviously, but I also did like an espresso tamping tool. It's used to like compress espresso before you put it into the machine. So I'm going to go ahead and open a model. So I'll say File, Import. So I see Tamp Tool V1. I went ahead and set this up. I just saved it as a step file from Fusion 360. So I select this, I tell it Open. So it imports a model. You can see this is the Tamp tool that I have. There are two different bodies. I just want the handle, so that's how I'm going to be focusing on. So what you want to do is you want to click the body that you want, and then you want to right click it. And then it comes up with a feature that says Convert CAD Body to Ntop Body. You click that. So the Ntop body is basically, it lets me work with it. It's a model format for Ntop. So this user interface is kind of different. It uses blocks. It's kind of like block programming. So each block is kind of like a filter. So you put a block, you stick something in one side, and you get something out the other. You can actually chain these up too, like you can filters. So you just put something in one side, it goes through one, then it goes to the other, and then pops out something on the other side. So you get these blocks either by up here in the menu or this really nifty search. And I find myself using the search more than anything. I really like that a lot. So this is basically where we're going to start from here. So I have an Ntop body. If you look in this upper right hand corner, there's these little circles. These turn on and off the model. So because we already converted it to an Ntop body, we don't need this here anymore. So we got rid of that. So we're just the handle. So I want to use this emboss feature. It's called a Voronoi emboss. So I just go up to the search bar and I type VOR. So you can see it's got a emboss and a deboss. Deboss will cut into the part, emboss lays on top of the part. So because we're creating a grip, I want to go with an emboss. So I click that. So that it basically gives us this little block here. And what it's asking me for input here is it wants a body. So the way you give it a body is by selecting the body you want and then dragging it to this box that says empty right next to body, and you let go. So this little guy going around means it's calculating the model, and then the lower left hand corner, this is a progress bar. So in our case, I want to give it a feature size of like 1, and I just basically click off the bar. So then you see it start to load, and we'll see what we get. So you can see very lightly are these cellular patterns here. That is due to these numeric inputs here. These control what you actually see. So thickness, for example, controls how far off the part this emboss goes, or how thick the embossment is. So right now we're at 0.1 millimeter, and it's just very faint lines. I could go up to say 3 millimeters, and I click off the box, and it's loading, and we'll see what we get from that input. So you can see that gives us a really thick one. I actually like that. I think I'm going to come back and do another screwdriver at some point that tries that out. But for my purposes, I went with 0.75. I'm printing this on an FDM machine, so that's just enough for the printer to kind of pick it up, and it gives you a really nice kind of grippy feel to it. So that's what I did on my screwdrivers. Another parameter you can change is cell count. So that's how many of these little boxes are on it. So if I change this to something really small, like 10, and let that load, I end up with a much different look, or a much different grip. You can even go down to something like 5 if you wanted to. You know, and it's almost nothing at all. You could go the opposite direction if you wanted to, until at 200. And so far, I really like that. I like in SolidWorks, you'd have to go and like edit your feature tree and like kind of dig through all that information. And I love just changing these numeric inputs and getting a different result. So yeah, that's a lot more cells here. Aesthetically, I really liked 50. So that's what I went with on one of them. So we'll do that now. Alright, so we got a 0.75 thickness, and we've got a 50 cell count, and that creates a really kind of nice grip for my screwdriver design. So now we want to get this out to something that I can 3D print. I'm going to run this on an FDM consumer level printer right now, and to do this we basically need another block. So the way to go to an STL in this case is by converting this ntop body to a mesh. So you can just type in mesh, and one of the neat things about the search bar that I found too is I kind of know what I want to do, and I can type what I think is correct, and it might take me a couple tries, but eventually I figured out what all the commands are here. So I knew I wanted to work with a mesh, so I just type in mesh, and it gives you a huge list. But one of the cool ones is mesh from ntop body. So if I click that, it obviously gives me another block. And it's the same thing we've seen already. It wants a body, and it wants a feature size. So in this case, I'll give it a feature size of 1. And that essentially corresponds to the resolution of the STL file. So 1 millimeter is pretty large, but we'll see what we get from that. So I grab the emboss, and I drag that to body. And it's trying to output it. And that was really quick. But it's, like I said, it's a pretty low resolution, and it's super jagged, and I would not end up printing that well. So I can come back over here to feature size, and then I can tell it I want a quarter, 0.25. So I click off, and it's loading, and this is a much finer mesh, so it's going to take a little bit longer to generate this, but I think we'll end up with a result that's much better for 3D printing. So you can see the mesh it generated, a lot smoother, a lot higher resolution mesh. So that's cool. So I got a mesh now, but how do I get an STL file? You go over here to your blocks, and you just type in export, or EX, and then it'll pull up all the export options, and you can see export mesh. So you click that and you get an export mesh block. This one's a little bit different though. It's looking for a path. So that's the save location. So if I click the file folder here, it'll pop up, and then I'll go to this exported folder that I've created. And it offers down here .ply, .stl, and .obj. I like a .stl file. And it's asking you what name do you want to call it. So I'm going to call this mesh 7. And I'm going to click save. But it actually didn't save anything yet. It just set where it's going to save and what the name is. The actual saving takes place when you drag the mesh that you've created into the mesh box. So to show that, I go to my exported folder, and there is nothing called mesh 7. So then I take this mesh and I drag it into the mesh box. And now, when I open exported, there's a mesh 7. So you go to something like MakerBot, and I just will start a new one. And then I'll say add. And let's add mesh 7, this file we've just created. There it is. You can now manipulate it for 3D printing. It's just a regular STL file. And that's my screwdriver handle. So next step, let's just run it to the printer, and then we'll see what we get from there.